Black holes, a sci-fi staple and something that most of us have heard of. But do you really know what they are and how they behave? If you ask a random person, what is a black hole? They'll probably say something like, it's a big void in space that nothing can escape from. And to put it bluntly, yeah, that's basically exactly right. A black hole forms when you put too much stuff in one place, all thanks to gravity. Gravity is an attractive force caused by matter. Any type of matter has gravity, even tiny objects like you and me, but the more massive the matter is, the more gravity it has. However, gravity is a pathetically weak force. Most objects are so tiny that their gravity is completely negligible. For example, if you were stood next to me, you would be attracted to me by gravity. It's just that that attraction would be so small, you would feel absolutely nothing. You can even see how weak gravity is for big objects. Take the entire Earth. That's a pretty big object. And right now its gravitational pull is desperately pulling everything here down towards the ground. But I can just lift my arm up straight towards the sky, the opposite direction to gravity, and it takes almost no effort. The Earth is pulling this figure here downwards as hard as it can, and I can counteract all of that force super easily and just pick it up. So it seems surprising that pathetic little gravity is the force that makes black holes so
inescapable.
Actually, any amount of matter can form a black hole if you smush it down into a small enough space. For most everyday objects, you'd have to crush them down to a subatomic size to get anywhere close to forming a black hole. You need the matter to get incredibly dense, because forming a black hole is all about density. Get some matter to be dense enough, and in a region around it, gravity will be so strong that nothing can ever escape its pull. This region is the black hole, and the shell around it that defines the point of no return is called the event horizon. Anything that crosses the event horizon can never escape the black hole and is doomed to end up in the center of the black hole. No matter how fast you try to travel out of a black hole, it's not fast enough to escape its gravitational pull. Think of the space inside a black hole like a waterfall carrying you inwards, and that waterfall is moving faster than the speed of light. So no matter how fast you try to move outwards, since the speed of light is the universal speed limit for stuff to travel, your net motion will always be towards the center. This waterfall space isn't really real, but I think it's a nice analogy to see why you can never escape the black hole. Actually, one cool thing about crossing the event horizon of a black hole is that, according to the maths anyway, time and space swap roles in the equations, meaning that your future is inwards. So it's not just likely that you'll end up in the center of the black hole. Once you cross the event horizon, it's inevitable. This means that the very center of a black hole must contain basically all of the matter that forms the black hole. This point is called the singularity, and it's a point of infinite density, because all of the matter is in one infinitely small spot. However, the singularity is hidden by the event horizon, which we can't see past, so we can never actually see the singularity. Or actually, we can't see anything inside a black hole. Although presumably, the rest of the black hole must get fairly empty because the singularity is gobbling up all of the stuff, so after a while, the rest of the black hole must look fairly empty, and the singularity just has everything in it. For the entire Earth, in order to get all of the matter that makes up the planet to form a black hole, we'd have to crush it down, ignoring the screams of the inhabitants of course, into a sphere that's about 9 millimeters in diameter, which is about the size of a marble. Of course, in reality, it's pretty rare for some omnipotent being to go around crushing matter down to form black holes. So how do they actually form in nature? As far as we know, most black holes in the universe form from the corpses of dead stars. Stars are basically enormous balls of fire, and they're very massive, so gravity is trying to collapse them down. But this is counteracted by the core of the star, which is basically a huge nuclear fusion reactor. It fuses elements together, a process which gives out huge amounts of energy, and this produces enough outward pressure to counteract the gravitational collapse. This is fine all the while the star has fuel to burn, but once it runs out, there's suddenly no pressure keeping the star up, and gravity finally wins, and it sends most of the mass of the star inwards in an
irreversible collapse.
This results in an object that's dense enough to form a black hole. Of course, this is the abridged version of this process, but I'll leave some videos in the description that go into more detail of stellar collapse and forming black holes. These black holes that form from stellar collapse can then grow by merging with other black holes to form a bigger black hole, or by accreting matter from the surrounding space. Accreting is just a fancy word that means to grow by accumulation, so it's just other matter falling into the black hole. And it's easy to remember this because the end of the word accreting is just the word eating. So it's just the black hole eating other material to grow bigger. In fact, these growing processes must be pretty effective because we've observed an incredibly large range of masses of black holes. We've seen them at just a bit more massive than the sun, which makes sense since the sun is a star and these black holes form from dead stars. So similar masses make sense. But we've also seen supermassive black holes, which are billions of times the mass of the sun. So they must have eaten an awful lot of space dust and merged an awful lot to get that big. These supermassive black holes are actually pretty common too. There seems to be one at the center of every single galaxy in the universe. I don't know of any other object in the entire universe that can have such a large range of masses. But if you do, then please let me know in the comments below. There are other possible ways for black holes to form too, such as so-called primordial black holes, which form in the very early universe as a result of quantum mechanical fluctuations. And actually, this is the only known way of forming a black hole with less than a solar mass. There also might be some way of forming a supermassive black hole directly, rather than forming a stellar black hole and then letting it grow, but if there is, we don't know what it is. However, since these methods are still hypothetical, let's just stick with stellar collapse here. At this point, let's address the common myth that black holes suck. This is not true, and I mean that literally and literally. First of all, black holes don't suck in the sense that they're not rubbish. They're pretty awesome, and I'm pretty sure nothing you can say can change my mind on that. Secondly, lots of people seem to have the idea that black holes suck everything into them like some sort of cosmic vacuum cleaner. And this isn't true either. I think they get this reputation because very close to them, they have a very strong gravitational pull. But that's all. They don't have any other property or force that means they suck in matter. It's just gravity. If black holes suck, then so does the Earth. And so do you. In fact, if you replace the sun with a black hole with exactly the same mass, then the orbits of all of the planets around the sun would stay exactly the same. Sure, it would get really cold and dark because there's no heat or light from the sun, but the frozen planets would keep orbiting exactly the same as if nothing has changed, because gravitationally, nothing has changed. Anyway, once you have some black holes, there are very few properties we can actually use to describe each one. Since nothing can escape a black hole, we seem to lose all information about the matter that actually formed the black hole in the first place. They all look pretty much the same. If you took a ton of sugar and a ton of lemons and squashed each of them down enough to form a black hole, you could never tell me which one formed which black hole. The information on the inside of a black hole is apparently lost for good. There is a chance that quantum mechanics, Hawking radiation, and firewalls might save the day here and save the information somehow. But again, at this point, this is all still hypothetical. Black holes all look so similar that there are exactly 3 properties that each one can have: mass, charge, and spin. Spin is also called angular momentum. No black hole has more properties than this. Now, you might think there's a fancy physics name for this fact, and the technical way we say it is black holes have no hair. Seriously, that's physics talk for black holes only have 3 properties: mass, spin, and charge. I know it's ridiculous, but it's stuck, and at this point, we can't change it. It's meant to convey the idea that you can't tell what the black hole formed from, that it has no hair that protrudes and gives you clues about the inside. And yes, physicists really do say it. And even worse is they go around saying you can't have a hairy black hole, and act like that isn't a ridiculous thing to go around shouting. Anyway, all black holes have mass, otherwise they wouldn't really exist, and a black hole that has no spin and no electromagnetic charge is called a Schwarzschild black hole, and is the simplest type of black hole you can have. A black hole that has charge but no spin is called a Reisner-Nordstrom black hole, after 2 of the physicists that first studied them. And a black hole that has spin but no charge is called a Kerr black hole, again after one of the first mathematicians to study them. A black hole that has both charge and spin is called a Kerr-Newman black hole, and the mathematics that describe it is really quite complicated. Get out of here! Each of these types of black holes has some unique and really cool properties we can learn about them. So stay tuned on the channel for that, and subscribe so you don't miss any of the cool cosmology that's coming up soon. Until next time, stay safe team. I'll see you soon. Bye! Get some matter to be dense enough, and the region around it will be fucked.